All right, perfect. Thank you all for joining. And just as a reminder, last class we finished module 2, and we are going to be starting module 3. And here we have with us Brahmachari Gurupriya Chaitanya ji from Anadi Foundation. And Mahodaya, why don't you introduce yourself and then we'll get started on module 3.
Am I audible for all?
Yes, Ji, you're audible and we can see your screen also.
Namaste, everyone. Let us begin with an invocation. Om Shri Gurubhyo Namaha. Om Shri Yoga Vidya Ganapataye Namaha. Om Shri Skanda Gurave Namaha. Om Shri Ashtadiklinga Pataye Anadilingaya Namaha. Om Shri Lakshmi Narasimha Swamine Namaha. Om Shri Lopamudra Devi Sameta Agastishwaraya Namaha. Om Shri Mahakriya Babaji Jnana Swarupaya Namaha. Om Shri Jagadguru Adi Shankaracharya Namaha. Gurur Brahma Gurur Vishnu Gurur Devo Maheshwaraha Guru Sakshat Param Brahma Tasmai Shri Gurave Namaha. Very happy to meet you all this Saturday morning there and a Saturday evening here. I am Brahmachari Gurupriya Chaitanya. I am the Pradhana Acharya here at Anadi Dharma Gurukulam. Long back, our founders, our Guru Dampati, they were my professors more than a little more than 2 decades back. I was a computer science undergrad student at Amrita University where I had met them. Since then, my journey has been there with my gurus. I did my BTech and an MBA. I worked in various tech firms, and then I had my own firm that I had started up for 5-6 years as well in the software industry. Following that, when Shriman and Matushri, our gurus, when they started Anadi Foundation, I shut down my firm and came here full time. Since the beginning of Anadi, I've been there. I've done the logo for Anadi. I've been with Shriman and Ma. I've been their child at their home for a long time. In fact, somewhere in those days when I was running my firm, I shifted full time my base to Shriman Matushri's place. Since then, I've been one among the family members here at Anadi. And when the opportunity was there for a spiritual pathway, I took up initiation in the Brahmacharya Marga. And I also continue to do my PhD work in my final thesis stages at IIT Bombay. I work in these regions, in the areas of Indian knowledge systems widely, and also I do my scholarly research, especially in the fields of Bharatiya Ganita and Nakshatra Vidya. Otherwise, here in Anadi, there are no compartmentalizations. We work on all domains at all times. I'm just coming right after finishing Mahanadana Seva at all the 6 Arupadai Veedu. We had the bhagya of serving more than 3,000 meals yesterday across the 6 Arupadai Veedu. And today also is the Purnima here, Purnima Tithi here in Bharat. And so we do a Girivalam. We are just, hot back after the Girivalam in the hot sun. Happy to meet you all and share some insights from Bharatiya Ganita in this module. One may ask often, there is this Ganita, there is math, but what can be Indian math? What can be this adjective to qualify, math as such, as Indian, non-Indian, or, I'm sure in the US, Russian math, many things are very popular. How do you even give an adjective to math, which is a very universal principle? Let me try this session to present a very comprehensive overview about what is the Bharatiya Ganita Jnana Parampara and what is this tradition and how are our approaches, how we have approached various mathematical problems over time and what are some among our marquee achievements and breakthroughs. And if I may have to ask this audience, I'm sure the August audience here already has good fair idea about Bharat's scientific tradition. If I may request some of you to name a few ancient Indian mathematicians, who might you say?
Bhaskaracharya ji.
Yes,
Aryabhatta.
yes, Bhaskaracharya.
Brahmagupta.
Brahmagupta, certainly. Yes, yes.
Leela,
Sorry, Ji. Not here, Rohit.
Leelavati,
Oh, Leelavati. Okay. Was Leelavati a mathematician? Okay. That we will see, certainly. Okay. Any other mathematicians that you might tell?
Pingalacharya.
I think Srini Raghavanji. When you unmute, we hear a lot of echo.
Oh, really? Okay, okay. Sorry about that. I said Parashara.
Okay. Parashara. Parashara was an astronomer, certainly. Yes.
Bhaskara,
When I go into full screen mode with Google, with Zoom, it works differently. With Google Meet, I'm not able to see any of you. So instead of raising hands, I may request or someone else to moderate, or we can freely speak in this meeting. That's also fine.
Gurupriyaji, I'm monitoring, so I can monitor chats at this point. Yeah. I think Ashwinji has his hands raised.
Ashwinji, we couldn't hear you.
Madhavacharya,
Madhava, okay. Madhava suffixes Madhavacharya makes someone else as Madhavacharya, like Shankaracharya. There was a great mathematician called Madhava for sure. Yes.
I see Dharamchandji.
Mahavir.
Mahavira, yeah. Mahaviracharya was a great Jaina mathematician. Ganita Sangraha he had written. Yes.
Bhaskara,
Yes. Bhaskara. So if we were to name a few of the works of these mathematicians, what might we say? We already heard the word Leelavati, Bhaskara. There is Bhaskara 1 and 2. So Bhaskaracharya the second wrote Leelavati. What did Varahmihira write? Someone said Brahmagupta as well.
Brihad Jatakam.
Yeah, in fact, he wrote 2-3 things in Varahmihira with respect to mathematics. Brihad Jataka doesn't have a lot of mathematics in it, though. Brihad Samhita has extraordinary amount of it's an encyclopedic work which has many things. Pancha Siddhantika has a lot of mathematics in it. These are all some Varahmihira's works. In this session, let us take the time to understand some among the phenomenal works that have been produced and phenomenal mathematicians. Why do they deserve the credit that they deserve? What exactly are the contents of some among their works and so on? This is a graph that I never start a course without showing. This is the Angus Madison study that's becoming quite popular these days. Angus Madison was commissioned by the OECD countries to estimate the gross domestic product contributions by various countries to the world over the last 2 millennia. And his estimates seem to conclude that about 1/4 to 1/3 of the world's GDP was evidently coming from Bharat. And this could not have happened. Today, the superpowers are all reliant on their R&D. The intellectual property makes a country a great superpower more than anything else. The military might, everything draws from very sound R&D. And if not for R&D in various domains, we would not have achieved the kind of signal status that we have had with respect to global excellence on various dimensions, including the economic dimension. We see that across the world, we were the Vishwaguru when it comes to a few things, especially the astronomical sciences, the medicinal sciences, mathematical sciences. agricultural sciences, psychological sciences, chemical sciences, and certainly even till today, we are still the Vishwaguru in the domain of spiritual sciences. With technologies, we had marveled the world with some among the leaps that we have made in shipbuilding, iron and steel, casting statues, iron and steel processing. Was held so close to the hearts of so many communities, and it had made India thrive globally in various dimensions. Similarly, water harvesting, phenomenal architecture and construction, textile manufacturing, town planning, name it, many domains. We were quite very advanced compared to the rest of the nation in terms of competitive advantage with respect to a nation. And hence, Indian civilization, India has certainly been the house of refined civilizational best practice. But not just that, but also for numeric scientific developments. Ancient Indian mathematicians, they achieved many significant breakthroughs. And they created wonderful pedagogical approaches which are very relevant to us right now with respect to teaching and learning math. We would gain a lot from now learning about how Indian mathematicians developed original ideas and how they approached various problems while retaining rasa. In the Indian tradition, Saraswati, Rasa, the Devi who adds rasa to anything is Saraswati Devi, and thereby she is the goddess of education. To keep up interest in something is phenomenally tough. To keep rasa happening and to keep the joy flowing, Devi is most essential. Where there is the right bhava, there the right manifestations automatically happen. And to enable us to keep the rasa flowing, Ma Devi blesses us in the Indian tradition, and it was phenomenally important in the Indian tradition to do things with rasa. And hence, a lot of joy of mathematics, understanding math can be derived from understanding how ancient Indian mathematicians approached problems very uniquely. Techniques to hone mental arithmetic skills, improving mathematical thinking. These are all some among the significant benefits of even now drawing from the rich well of the treasure trove in Indian mathematics. David Mumford is a Fields medalist, and Kim Flofker, one among the graduates from Brown University who studied mathematics in India, when she authored this book on mathematics in India. This is still has a lot of Eurocentric views to it, Kim Lofker's book, but however, it has been eye-opening to the Westerners about mathematics in India. If you ask me, would I recommend this book? I would recommend you going through it, definitely. But you can definitely, a keen eye can anyways pick up biases here there. The review to this book, David Mumford writes, did you know that the Vedic priests were using the so-called Pythagorean theorem to construct their fire altars in 800 BCE? So 800 BCE, how do we date Vedas? So this is a very tricky field to do historical dating on an oral tradition, such as that has been there in Bharat. And so the modern scholarly concurrence is that the Rig Veda could be as old as 800 BCE. However, there are various other researchers who dated back at least 27,000 years back and so on. So it's the game of dating the ancient texts, the very ancient text is a slightly tricky place. But we can be sure that at least as early as 800 BCE, we had this knowledge. Right? That way, we make it less than or equal to 800 BC. So he says that we had the Pythagorean theorem and so many other geometrical theorems we had developed by then. In Bharat, a lot of math originated from geometry. So very unique approach to understand math. Today, when we look at the construction of many of our textbooks, they start from plain arithmetic and go into algebra, while geometry and mensuration are relegated to a time and space where today we don't see great practical applications unless and until you are making yantras like this, the Sri yantra that's above me. You are not really doing geometry unless and until you are doing, if you're just drawing arcs and measuring angles. You're not doing intensive geometry as ancient Indian mathematicians did. And through geometry, they arrived at various algebraic identities. They made arithmetics extremely powerful, extremely uh, inclusive, extremely available to everyone, and very simplistic to use thanks to the geometrical origins of various mathematical ideas. And for that, the Vedic times have played a very important role. He goes on to say that the differential equation for the sine function in finite, that is, if I have to supply the word its, in its finite difference form, was described by Indian mathematician astronomers in the 5th century CE. Any guesses as to who could this be? In the 5th century CE, giving us the differential equation for the sine function.
Aryabhata?
Yeah, Aryabhata. Aryabhata was 23 years old when he composed the Aryabhatiya. In the modern day Pataliputra, Patna, was the kingdom of Magadha, was the capital of the Magadha kingdom earlier, called Kusumapura. So there he had presented the finite, he presented the Aryabhatiya, in which there is a pada, a quarter of that is Ganita pada, which only 23 verses. A quarter here does not necessarily mean exactly a quarter, but one of the 4 components of the Aryabhatiya is the Ganita pada, which only 23, just only 23 verses. And it is intensely terse, if not for some among the commentators of those times, Bhaskara 1 in 623 CE, if 629 CE, if he had not written Aryabhatiya Bhashya, we might not have understood any of the things that Aryabhata has ever said. And thanks to the satellite launch vehicle launched by ISRO in 1970s, in the name of Aryabhata, it has become a household name. But otherwise, our larger understanding of Aryabhata is he invented the greatest contribution by Indian mathematics to the world is zero, the notion of zero, and that it was Aryabhata who invented it, are both myths that need to be busted. No, we are talking about 5th century CE, where we are looking at advanced trigonometric functions and finding the rate at which these functions change and so on, right? This is 5th century CE. And today, what we call as the Gregory series, Newton-Leibniz series, and so on, were all brought out in the 14th century in the southwest India. This he is referring to Madhava. The pi by 4 infinite series was proven using the power series for arctangent, and with ingenious summation methods used to accurately compute pi in the southwest India in the 14th century. We knew pi accurate to 11 decimal places in Bharat, and that kind of applications are only in very nuanced sciences you need such sort of approximations to pi. And another very unique aspect to Indian mathematics, and that applies to all Indian fields of Indian sciences, to all fields of Bharatiya Vijnana, is that they are written in either sutra form or in padya form. The sutras, which are terse sayings, or in delightful verses, which are padyas. A good amount of commentaries are in the gadya or the prose form. However, you will see a lot of poetry within the commentary also. New problems forged, new proofs written, new explanations presented, new pedagogical approaches revealed. All that are there in the commentaries. So the commentary was not a requisite in the Indian tradition to read thoroughly. However, the source text was. The source text always, the Moola Grantha and Bhashya Grantha. The Moola Grantha was always committed to memory. And in order to help committing it to memory, it was always designed in a way that it's in a poetic form, and that is easy to chant, easy to recite, and commit to memory. This, is a sort of a yeoman service made by ancient Indian Vijnanis. All the Vaigyanika Chintana Medhas were really adept in writing beautiful compositions that helped the pedagogical demand to not carry books, to be completely self-reliant, to carry everything through the Shravana mode of learning. Through active listening, you could almost manage learning anything in the Indian tradition. Now, this demands of a person in the Indian tradition, be it in Ayurveda, be it in mathematics, to conform to a particular meter, pick a meter, compose things in that meter, and make it available for people to access that knowledge very easily so that they can recite it. And a good amount of primary education involved chanting and by hearting these verses, and over time unraveling them one by one. A classic example that really moved me when I started studying Indian math, and it's a profound example that packs a lot of dimensions of pedagogy in Bhaskaracharya's Leelavati. Bhaskaracharya's Leelavati was a very profoundly popular text in Bharat. Almost so many copies of this manuscript are available, talks to the popularity of that text. And in that text, there are 272 verses. It was written in the 12th century CE by Bhaskara II. He belongs to Chalisgone in Maharashtra. And Bhaskara composed a collection of beautiful verses that are very interesting for children to learn, recite, chant. He was a huge poetic genius, not just a mathematical genius, and thereby led to the popularity of this text. The text is called Leelavati. Faizi, the court mathematician of Akbar, translates Leelavati into Persian language. And in the foreword to that text, he writes that Leelavati was the daughter of Bhaskara, and the fabled tale that we know that Leelavati was to get married at a particular time when she bent over, her pearl fell into the Ghatika Jala Yantra, and it stopped and they missed the time and so on, and thereby she didn't get married. So all these things that we know of the fable of Leelavati are written by Faizi. Faizi says he gathered this information from a few local panditas that Leelavati was the daughter of Bhaskaracharya. However, within the Moola Grantha or in its Bhashyas, we do not find exactly who Leelavati is. But going by this fable at least, if Leelavati was indeed the daughter of Bhaskaracharya, then he is asking this question to a 10-year-old. Okay, as per Faizi's account. Certainly, Bhaskaracharya did name his text Leelavati, and he addresses a child called Leelavati throughout the text. He also addresses various children in plural form, singular form, thereby making it abundantly clear that this is a Prakarana Grantha, or it is a text that is more introductory in nature. It's a text that is more educative and enjoyable by children, and it's a pedagogical tool. It becomes amply clear. The 272 verses can be broadly classified into Sutra verses and Udaharana verses. Verses that talk a principle and verses that talk about its applications through either examples or through puzzles and so on. So here is a puzzle written by Bhaskaracharya in the 19-syllable meter called Shardula Vitriditam, the play of the tiger. It goes like this. Parthah Karnavadhaya Marganaganam Prudhorane Sandadhe Tasyardhena Nivarya Tacharaganam Mulai Shaturbhirhayan Shalyam Shadbhihi Atheshu Bhistribhirapi Chatram Dvajam Karmukam चिच्छेदास्य शिरशरेण कथिते यानार्जुनः सन्दधे. It goes like that. It picks up an episode from Mahabharata and turns that into a quadratic equation based puzzle for Leelavati to solve. He says Partha is doing Karnavadha. Partha comes in the Prithu lineage and it refers to Arjuna here. We all know that. Sadly, in Tamil Nadu, Partha Sarathi has been truncated into Partha a lot. Partha Sarathi is in fact Krishna. So Partha is doing Karnavadha. And he is raining arrows. Margana Ganam. Just raining a huge, unknown number of arrows. In the Ghori battlefield, Kruddhorane, the Ghori battlefield, he is continuously showering arrows. Of those arrows, half of them, Tasyardhena, with half of those arrows, Nivarya, for Nivaryam he used, for the purpose of defense. Half those arrows are used. Okay. If I have to turn this into an equation, let X be the unknown amount of arrows. Half of them, X by 2, is used for Nivarya, self-defense. Then Tat Sharaganam, of those unknown quantity of sharas, Mulai Shaturbihi Hayane, 4 root X was used to tackle the horses of Karna. Mulai Shaturbihi, with 4 times 4 root of those unknown quantity of arrows, the horses of Karna were tackled. Then Shalyam Shadbihi, 6 for Shalya. Who's Shalya? Oh, you were all having a peaceful Saturday morning. Now I'm throwing questions at you. Who is Shalya, do you think?
Karna?
Sorry, Ji.
Maternal uncle of
Nakulan Sahadeva.
yeah, Nakula Sahadeva.
Maternal uncle of
Karna's charioteer, no?
Karna Sarathi is Shalyam. So Partha Sarathi is Krishna and Karna Sarathi is Shalya. So a max class now diverges into some Mahabharata episodes where Shalya, being Madri's brother, he comes with one Akshogini of warriors, and as soon as he reaches the close quarters of Kurukshetra, like how they give great hospitality in many places. The moment you enter a hotel or a resort, they welcome you with a welcome drink and so on. So he's welcomed with a great feast. The entire Akshogini of warriors are given a grand feast, welcome feast. While eating the food, assuming it can be his own sister's sons who have arranged for this food, he claims loudly that to those who have given us this food, we shall give our lives to. And just then, Duryodhana walks in. Duryodhana is called, however, the name he was given was Suyodhana by his parents. Then he has become a Duryodhana. He walks in with his entourage and claims that it is me, after all, who has arranged this elaborate meal for you. And having given his word that he will give the lives and his entire army will give the lives for the one who has fed them sumptuously that day, it so happens that he has to join the Kaurava side. Otherwise, the 7 Akshoginis versus 11 would have actually been 8 versus 10. Right? And so, Shalya, it's in fact Krishna Bhagavan who advises Shalya to become the Sarathi of Karna. And to immobilize him, Arjuna uses Shadbihi, 6 arrows. Atheshu. Following that, Atha, no, Atha, following that, Ishu with the arrows, Ishu bihi with the arrows, Tribihi, Ishu bihi with 3 arrows, right? What does he do? Api, he also attacks the Chatram, Dhwajam, and Karmukam. Chatram, what would it be?
Umbrella.
The umbrella of the chariot of Karna. So these days, the picturization does not do great justice to the phenomenal Maharathas of the Mahabharata times. However, the Chatram was demolished, the Dhwajam, the flag of Karna was demolished. Karmukam is the bow of Karna. That was demolished. Finally, Chichedasya Shiraha. Finally, one was aimed at the head of Karna. Katithe Yanarjuna Sandate Sharena Gatite. Kati Sharena Te Yanarjuna Sandate. How many arrows were employed by Arjuna? Is the question. So x by 2 for defense, plus 4 root x for the horses, plus 6 for Shalya, plus 3 for Chatram, Dhwajam, and Karmukam, and plus 1 for the head of Karna. All this amounts to the unknown quantity x that we have. So if you were to simplify this equation, you will get x minus 8 root x minus 20 equal to 0. This is what you would get if you simplify this equation. If I were to substitute root x as a, this becomes 8a, then x will naturally become a square. So a square minus 8a minus 20 equal to 0. If you find the solutions for this quadratic equation, you will get solutions for a as plus 10 or minus 2. And hence minus 2 arrows can't be employed. So a will be 10, thereby a square is x, and that will be 100. And this was sort of the expectation of a very small child to solve in the Indian tradition. Very interesting way to first model a problem mathematically, find the equation in it, and then solve it diligently. But today, all we hear is solve for x, and then we find an equation in front of us. We are lost in abstraction when it comes to mathematics. Moreover, there is Yuddha Niyati as well embedded in this verse. We see that the greatest number of arrows that are employed are in defense. The Yuddha Niyati states that you don't go to kill your opponent directly. You give him ample chances to surrender, to cede in this battle. If you were to show that you're given enough chances to cede, all your arrows are thwarted, then your horses are thwarted, then Shalya is unstoppable. Even if the horses are not there, he's now running the chariot himself. Then Shalya has to be immobilized. Then slowly the chariot is brought down. All this while, it is not Karna who is directly attacked. Karna is given a continuous chance to surrender, and that is Yuddha Niyati in the Indian tradition. So we see all that embedded in this beautiful verse in Shardula Vikridita. And this sort of pedagogy is what we had in ancient Indian mathematics. Moreover, the expectation was to solve everything mentally, to also create a pedagogy that will enable you to solve all this mentally. It's not just only the expectation, but to be very diligent when it comes to solving puzzles.
Gurupriya ji, there are a couple of folks with questions. So
Please.
the DCG and Deepti ji, go for it. DCG first.
I think it was from my prior question. I'm good.
Okay, Deepti ji.
Was this a real life problem? Like, actually, he used 10 arrows that morning, or were these problems made up to explain concepts?
Yeah, they were made up problems. I mean, never in the Mula Grantha of Mahabharata you find details of a mathematical puzzle.
Ah,
However, it is the Puranic episode that captures, right, phenomenal the mind of the children. It's a phenomenal conception of a problem in itself. I wouldn't really use the word made up here, but to concoct and conceive a problem like this is quite interesting. However, it's drawn heavily from the events of the Mahabharata, very closely attacking Shalya, then the horses, the entire sequence. And we belong to a tradition of Shrautas, right? The Shautis. Shautis were Tapasvi storytellers initiated by Vyasa Bhagavan himself. And the Tapasvi storytellers brought out the event in great detail to others. Other than only reciting the Mula Grantha, they were also bringing out, and then they were discussing, these great details to, So Bhaskaracharya is very adept in so many domains. In Pauranika, in the Mimamsa, Purva and Uttara, many domains of knowledge. He's quite adapted. So he is also very good in conceiving such problems, drawing from various, Indian inspirational sources, as well as capturing the rapt attention of his listeners. Okay. If there are no other questions. Now, this kind of poetry, right? This is what was incumbent upon the Indian mathematicians to create such work. They challenged themselves to create such works, and they explained principles. They presented fantastic. There will be a bird migration problem with quadratic equations. There will be a lot of flora, fauna, nature. Great values such as dana for continued fractions, fractions of fractions of fractions, and so on. So these kinds of efforts made a phenomenal learning experience. If we have to look at Indian mathematics, we largely think of the word Vedic mathematics. Vedic mathematics was made popular by Swami Bharati Krishna Tirthaji, who was the Shankaracharya of Puri until 1960. He comes along the Atharva Veda tradition. And the Swami says in the recension that he had, the Shakha that he belonged to, he has come across 32 sutras that help do mathematics very diligently. He made 16 of them main sutras and 16 of them upasutras. And he never completed the book that he intended to. However, he had lectured everywhere back then itself. In Oxford, so many other universities he had lectured. He was an avid mathematician before becoming the Shankaracharya himself. His book was compiled by his Sishyas, his incomplete book. He said that all of mathematics, even the higher order math, are possible with these sutras. But unfortunately, he couldn't complete his book. But posthumously, after the Shankaracharya passed away, his Shishyas came together to publish what was remaining of those books. And that became the Vedic mathematics book published in the authorship of Swami Bharati Krishna Tirthaji, the Puri Shankaracharya. And thereby the word called Vedic mathematics became very popular. Some of the techniques in it have a direct influence when you see even the various other speed mathematic traditions that we know of are all highly influenced by the book of Swami. So that's why we are careful to use the term Bharatiya Ganita and we do not use the word Vedic Ganita per se, because the word Vedic mathematics has become synonymous to the book and the set of techniques that Swami has initiated. However, the Bharatiya Ganita in itself and the developments of the Bharatiya Ganita can be broadly classified into three key eras where major jumps in mathematics had happened. The Vedic era or the ancient era, it dates back to the ancient period. It dates back prior to 500 BCE. Then 500 BCE to mid 14th century, that is 1350, is considered the Siddhantic era or the classical era. Then comes the post-Siddhantic or the medieval era from 14th to 18th century CE. The last remaining true mathematical or astronomical work that we see is of Samanta Chandrasekhara Saraswati from Odisha. And these are all some among the true to the Indian mathematical traditions. We can see some among these books. Even Achyuta Pisharati, Shankara Varyar, and so on, as well in the Kerala traditions. This, over these three periods, what are some among the significant jumps? This all Bharatiyas in spirit must know about these three key eras and the key contributors in these three eras. Mahaviracharya in Ganita Sara Sangraha. So I study under Professor Rama Subramaniamji at IIT Bombay, and the first verse he ever taught to me is this, and thereby I put this verse everywhere, inside his slides as well, my slides as well, everywhere. This is a very, very fantastic verse of Mahaviracharya. Ganita Sara Sangraha is his text, in which in the 9th century, this Jaina mathematician Mahaviracharya writes, Laukike Vaidike Chapi Tatha Samayike Piyaha Vyaparastattra Sarvatra Sankhyanam Upayujyate Kamatantre Arthashastre Sagandhargye Natake Piva Supashastre Tatha Vaidye Vastu Vidyadi Vastushu. He goes on, these are the first and second verses. So he says, be it the Laukika activities, be it the Vaidika activities, or the Samayika, the societal activities, any transaction, Vyaparastatra Sarvatra, Sankhyanam Upayujyate. We use enumeration in all these factors, all these three dimensions. Kamatantra, be it in Kamatantra, be it in Arthashastra, in Gandharga, all the entertainment shastras, Nataka, that is the music and dance, then the Nataka Shastra, Super Shastra, be it in cooking, he says, Tatha Vaidye, in medicinal sciences, Vastu Vidya, the architectural sciences. In all of these Vastus, in all these domains, he goes on enumerating like that. These are the first, second verses, the third, and up to 13. He keeps enumerating various domains. Chando Lankara Kavyeshu, Tarka Vyakaranadishu. He says, be it in Chandas, be it in Alankara. See, the mathematics in Chandas, we must know. We'll study about the combinatorics and the binomial theory and its presence there. We'll look at some among the early computational thinking that are given by Pingalacharya in the upcoming modules later. In Chandaha, Alankara, in Kavya, Tarka, Vyakarana, of course in Vyakarana, right? So in Kalaguna, basic, any, be it any dimension, Prastutam Ganitam Param. In all this, mathematics plays a very significant role. Bahubhir Vipralapai Kim Trilokya Sacharachare. Why keep talking too much? In Trilokya and the three lokas, Bhur, Bhuvaha, Swaha, in all these three lokas, be it Achara or Chara, right? Be it Sachara or Achara, that is Chara, Achara, all the living, non-living beings. Yatkinchit Vastu Tat Sarvam, be whatever that it may, right, in all these entities. Ganitena Vinanahi, whatever be the transaction, it cannot be executed without mathematics, he says. So this kind of introduction alone, is a great motivation to begin a mathematical book, right? Today, mathematics books don't talk about Where is the matrix applied? Where is something applied? Where do we talk about many of this, right? It goes into a direct abstractional concept. Indians, it's not that Indians shunned away abstraction. They were quite adept in abstraction, but they heavily focused on application. For them, application was very important. It has to be part of their life and reality. It has to be dharma sapeksha vijnana, not dharma nirapeksha vijnana. It had to be as part of their dharma. In the West, it is always religion versus science. It has been like that so. And hence, it has severely influenced their thought processes. However, in Bharat, dharma, the Sanatana dharma and vijnana were very supportive of the demands in various Vaidika karma, various Samayika karma. Samayika karma involves building temple tanks, building water bodies, being many societal activities that you do together as a society, right? All these, many of these facets, started demanding higher and higher accuracy in mathematics and in calculations, and thereby motivated different streams to push the boundaries of mathematics. And in fact, then mathematics also pushed accuracy and conceptualization and even invoking the divine mathematically, in so to speak. So, other than not just giving such a very beautiful poetic motivation to mathematics, Mahaviracharya also writes so many, wonderful applications to puzzles based on some among the fantastic domains that he has enlisted here. He has written fantastic puzzles from drawing mathematics out in all these domains. So in the village of Pavaluru in Telangana, modern day Telangana, there was Mallanna. So Pavaluru Mallanna drew inspiration from Ganita Sara Sangraha, and he wrote a Telugu mathematical text in the 11th century, 2 centuries later, called the Pavaluru Ganitamu. I've long been longing to find people to co-research this Pavaluru Ganitamu. If some of you here are Telugu enthusiasts, we'd happy to collaborate on those dimensions as well. So he has drawn from this, and he brings out his own unique, brilliant puzzles. He brings out Vanadevi. Vanadevi wants to come and gobble up people. There are 30 bandits and 30 panditas. And the Vanadevi now wants Bali, Narabali. So the panditas and the bandits there, they argue with each other, and they want to see who must be given Bali. The bandits make an argument. See, these panditas eating a lot of ghee-based food are very sumptuous for you, Ma Devi. You must have them. The panditas in turn say, no. They come up with a solution. They say they intelligently arrange linked list data structure, so to speak. If all of you are computer science enthusiasts, you form this circular formation where the first person who has the pointer number 1 and starts counting 1, 2, 3, 4, 5, 6, 7, 8, 9. Every 9th person, Ma Devi can eat. The Panditas say, given the condition that you must stand in the arrangement, we ask you to stand. So he, at the end of Ma Devi, counting the circle is formed, starting from 1 person. Every 9th person, Devi keeps eating. What kind of circular arrangement must be made so that it so happened that the Panditas survived, all 30 Panditas survived, and all 30 bandits, the dacoits, got eaten by the Vanadevi? What was that formulation that the Panditas came up with? Is a question in Pavaluru Mallanna's Pavaluru Ganitamu. So these kind of inspirational content is available in so many, not just Sanskrit, in so many vernacular texts in Bharat as well. So that gives a glimpse, but I want to delve a bit into all these 3 periods in the Vedic era, we clearly see in Indus Valley civilization existence of mathematics, right? We see urban planning and geometry available there. A lot of practical geometry that was needed for city planning was well known. Perpendicular roads, cardinal directions, aligned roads. All this needs mathematical calculations. Great geometric sophistication, clear application of the right angle theorem, right? Evidence of all geometric understanding in pattern creation, which means you must be good in geometry to create patterns, right? Including the utilization of circles and triangles in their pottery, we can find. We can see various artisanal tools such as dividers and so on for scratching designs on pottery. We can find also various geometrical motifs such as triangles that indicate various concepts. Weights and measures clearly show that they knew all foundational arithmetic operations very well back then. And then brick building technology required them to build bricks at different ratios and we make symmetric bricks of different ratios, showing that they had knowledge of binding strength, brick construction technologies, voluminal understanding, and so on. But this is inferential knowledge. However, we see in the Rig Veda itself, the decimal place value system is there. So if someone asks you what is India's greatest contribution to mathematics, it's not 0. It's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's this decimal, notational system that we have right now. And sthanat sthanam dashagunam syad. From one sthana to the next sthana, it's a power of 10, or, it's a multiple of 10. Making it a decimal value, notational place value system is Bharat's greatest contribution to mathematics. It is not just 0. All of Europe was submerged with Roman number system and crippled by it until 14th century. XCVIII into LXCVI. How would we even compute this? Right? You may on your own time definitely Google up how to do computations, especially multiplications in the Roman number system, and you will clearly understand how incredibly for a lack of another word, stupid that system is, and incredibly limiting that system is for people. Roman traders literally had to use and employ calculators, human beings called calculators, who would carry their long papyrus sheets around and keep doing calculations on the accountings that were needed, and it was really not an accessible arithmetic system at all. However, it took them all this time till 14th century, and we are talking about a time where Bhaskaracharya is writing quadratic equations and helping a child solve it, versus another system that is not making math accessible. That's the kind of contrast that we are. And even now, the traces of Eurocentrism is very much stuck. That around the world, we still learn this Roman number system. What kind of Eurocentricity that we are still colonized minds and colonized educations that we still have this Roman number system as part of our education, which is absolutely useless and absolutely purposeless in the current context, except for might be knowing and recognizing certain letters. Okay. There are several mathematical concepts that are dealt with in the in the Vedic mantras. The knowledge of operations of addition, subtraction, multiplication, and division are evident from looking at these mantras. There are also several progression series mentioned in them. We have written very detailed blogs and articles about these as well. So if you see in the Yajurveda Samhita, we have this power, values of all the place value notations named Eka, Dasha, Shata, Sahasra, Ayuta, Niyuta, Prayuta, Arbuda, Nyarbuda, Samudra, Madhya, Anta, Parartha. All this we have in the Yajurveda Samhita as the powers. And unless and until you have large numbers and you have the need for large numbers, why would you even name those large numbers and work with them, right? Similarly, the same list occurs in Taittiriya Samhita, Maitrayani, and the Kathaka Samhitas as well. Similarly, the classification of numbers into Yugma and Ayugma was already present in the Atharva Veda. Yugma means even number, Ayugma means that which cannot be paired, right? And hence an odd number. 0 has been called Shudra or Trifling. The negative numbers are called Anricha, and positive numbers are called Richa. Basically, without debt and with, with without debt and with debt, right? And this was there in Atharva Veda. Similarly, we see a great amount of the earliest known mathematical text in the Indian tradition. We can trace it back to the Shulpa Sutras. The Shulpa Sutras are part of the Kalpa Sutras. So the Vedanga, there are Shad Vedangas in the Indian tradition. They are the Shiksha, Vyakaranam, Kalpa, Niruktam, Jyotisham, Chandas. So in the order as we see in the Upanishads, we have written them here. So Shiksha, right, deals with, would anybody know what does Shiksha deal with? Vyakaranam, I'm sure all of you know. Shiksha, Niruktam.
Shiksha is education of
Phonetics.
Shiksha is phonetics. Niruktam is etymology. Vyakaranam is grammar, we know. Jyotisham, we know, is Dikdesha Kala Nirnayam iti Jyotisham. So it was astronomical sciences. Jyotisha later branched into Phalita Jyotisha and Ganita Jyotisha, making it predictive sciences, astrology, and the astronomical sciences, Ganita Jyotisha. Chandas deals with the meters, poetry, and prosody, the metrical patterns. So we see that actually math was there in all these 6 Vedangas. We will have the time to look at Shulpa Sutras and later Chanda Shastras mainly. Jyotisham might be later in part of the module of this course. Shiksha and Niruktam know that they are mainly rules very similar to Vyakarana in terms of how addition and subtraction of sounds matter in Shiksha and word formulations matter in Niruktam. In ancient times, all these branches used to be studied by Vedic scholars along with Vedas. We know this even now in the Chaturmasya period. They used to focus more on the Vedangas than the Vedas themselves. But it is inside the Kalpa Shastra, the Kalpa Vedanga. In the Kalpa Anga of the Vedangas, what we see is they are basically instruction manuals for various religious practices, including various Agni Karyas, various important Vedic rituals. Whereas part of that, Shulpa Sutras were the construction manuals for constructing fire altars. And in them, we find great depth in dedicated to geometry and geometrical theorems, properties, applications, and so on. The 8 schools, the 7 schools of Shulpa Sutra, the sutras that have survived right now are Bodhayana, Apastamba, Katyayana, Manava, Maitrayana, Varaha, and Vadula. The Bodhayana, looking at the textual analysis, scholars have said that this is the earliest of the Shulpa Sutras. Bodhayana is dated as the earliest, and this is authored by Bodhayana, and it is made up of 3 chapters constituting about 520 sutras. And we see that it contains various geometric procedures, fire altars, and so on. Was there a question or a hand raise?
There's just a discussion, Jeet. There was a question by Shivkami ji asking if the fire altars are the Yajna Kundams, and I think the answer was yes.
Yes. We see that they had different kinds of Yajna Kunda. You'll see some of them. However, the 12th sutra in the first adhyaya of Bodhayana Shulpa Sutra has the Bhuja Koti Karna Nyaya, also simply called the Shulba theorem, or that is right now called the Pythagorean theorem as a misnomer. In fact, Pythagoras himself did not come up with it. It's the Pythagorean school that they later came up with the theorem there and thereby named it Pythagorean theorem. We see that in the Sutra Rupa here in the Bodhayana Shulpa Sutras. Dirgha Chaturasya Kshnaya Rajjuhu Parshvamani Triangmani cha yat prithak bhute kurutaha tatubhayam karoti. He says, Dhirga Chaturam. Chaturashra. Ashra means side. Chatura Ashra means four-sided figure. Okay. A Chatura Ashra is a four-sided figure. A Dhirga Chaturashra is an elongated four-side figure, basically. He says that the Akshnaya Rajju, the rope, the straight Rajju also means rope or the straight line that connects the diagonal that connects the two edges. This measure called Akshnaya. This Akshnaya Rajju, if you see, Parshvamani Triangmani. Parshvamani, the horizontal side. Triangmani, the contesting vertical side to it. Yat prithak bhute kurtaha. The area that you can build using this side as your square's base side and this side as your square's base side. Thereby, if you build an area like this, with this one side, it will be b square. With the other side, it will be a square. This, what is separately made by them, is together made by the Akshnaya Rajju. When we make an area with that, is what the theorem says. And just to clarify, right after it, he gives all the Pythagorean triplets in the next verse. He gives examples of 3 square plus 4 square is equal to 5 square. He gives various, at least 7 Pythagorean triplets, he says. Apastamba has even more elaborately worded this compared to Bodhayana. All of them dating prior to the entire Pythagorean theorem. And we very clear that without knowing this right angle application, even now Masons, how do they figure out, how do they create, the base? When they form the foundation, they first create the base markings, right, for a building. They go do a 3-4-5 ratio at the corner to see if they've got the 90 degrees right, even now. So this, in the roofs, in the constructions of the earlier times, are very visible that this was a well-known theorem and it has huge applications when it comes to mathematics, especially constructing angles and so on. Let me turn off the... Yeah. Similarly, the quest for pi, it began in constructing 3 primary altars called the Treta Agni, the Garghapatya, Ahavaniha, and Dakshinagni. This is the Garghapatya, the circular Agni Kunda, Ahavaniya, the square Agni Kunda, and the Dakshina Agni Kunda, which is the one in the semicircular form. The constraint to building these 3 Agni Kundas was that they had to be having equal surface areas. Had a very good time looking at this, how they had constructed this Agni Kunda even now in the Nerur Shankara Matam here. And it's usually made, this is for Agnihotris, and it is made to the dimensions in a ratio that is specific to the dimensions of the person who's conducting the yajna all the time. Usually it is made with the to the dimensions of the scaled to the dimensions of the yajamana of the yajna. So this quest for pi began here because you had to square a circle and circle a square, and thereby you had to arrive at the ratio between the circumference and the diameter of a circle, which is today, was much later by a German mathematician in the 1700s, named as, given the term pi to it, and thereby it got stuck as pi right now in our modern abstract mathematics. Otherwise, we always knew it as the ratio between the circumference to the diameter. You take a line, you rotate it 360 degrees, it forms the outer circumference of a circle, and this line becomes your diameter, right? So this makes it, in fact, the ratio between the circumference to diameter, which was well known in the Indian tradition. So how do you circle a square, make the square a circle of equal areas? All these we find in the Sulba Sutras. which led to the quest for pi, and then they are approximated pi to one up to approximately 1 decimal value. They built very complex chitis like Shena Chiti, Kurma Chiti, Matsya Chiti, Rati Chakra Chiti. So all this Ratha Chakra Chiti and so many other formations. So every time they had to this Shena Chiti, all is very complex yajna. Very, very rarely people do this. I mean, because you had to do a lot of dana while doing this yajna. And you had to continue commit to doing this yajna once every 5 years. You have to continuously do it. So first year you build a layer like this. Second year you build the layer on top of it like that. Third year you again build this. So odd numbers will have figure 1 as its layering mechanism. Even numbers would have figure 2 as its layering mechanism. They had all these specifications in the ritual, thereby, putting mathematicians to the task of building the right building blocks, arriving at rational approximations for root 2, because it's the diagonal of a unit square, right? So they gave this beautiful equation correct to 4 decimal places, giving root 2's value correct to 4 or 5 decimal places. This equation gives. So if you look at the Bodhayana Shulpa Sutra, it has Rekhamana Paribhasha, Chaturashtra Karnopaya, that is units of linear measurement, construction of circle, squares, rectangles, various prescriptions for them. How do you do it? How do you do it when it comes to these areas and so on? Then theorem of the square of the diagonal, we saw that right now. Then transformation of geometrical figures by area preserving transformations, these were, right? When you had to transform one, and some of them, right, or also look at this, right? They are, various figures, and if you had to preserve areas at certain places, what you had to do and so on was there. Then Nana Vida Vedhi Nirvanam. So plans for various fire altars, such as the one that we saw right now. Then what must be their areas, right? Pramana Kshetramanam. So what must be their areas? Then Ishta Sankhya. How do you, sort of arrive at the requirements when it comes to this is the plan that you have? What kind of ratios must you apply to the number of bricks that you need? What are the scaling parameters, and how do you estimate the requirements of the bricks, their sizes and shapes? Then parameters for choosing the materials in brick making, the process of manufacturing bricks themselves, then the descriptions of the shapes of various fire altars, especially the Shena Chiti. All these are found in the Bodhayana Sulba Sutras in the 520 odd verses sutras. These were all some among the complex formations that they did as well. So in this era, we saw that rectilinear and curvilinear geometrical objects, they could build very well. Enunciation of various geometric principles, area preserving transformations, value of surds, estimating a surd from a sequence of rational numbers. In fact, the very word surd has an absurd story when in connection to it. So this in the Indian geometry, to name sides, we call the lateral sides as the bhujas, right? As bhujas, the lateral sides, and the diagonals as karnas or akshnaya, karna. These are all some of the names. Karna is also ear, right? When you can't estimate this perfectly using a rational number, then they would say that this is akarna. You cannot exactly find its value because sometimes it's non-deterministic, like root 2. If this was 1 and 2, this would be root 5. So now root 5 or root 2, or in some cases root 3 and so on, are not really, are all surds. So how do we bring a sequence of rational numbers, a rational approximation for the irrational numbers? So Hipparchus very famously said this, and he himself was called irrational. We still call these numbers irrational. Third, this akarna means, literal translation also became deaf. Deaf in the Greek, especially in Latin, got translated to surd, and that's why we still call them surds or deafs. Okay. So there were different methods proposed by different scholars to arrive at root 2, root, pi and such, expressions for these as well. This is all going back to the Vedic era in itself. Was there a question here? I saw a ping.
Yeah, there was a hand raised by Darshanji.
Yes.
Yeah, I just wanted to check whether Chittis is again Yajnakundas.
Sorry, Ji, I could not hear you.
I was asking whether Chittis that you mentioned, right? Is that also Yajnakundams?
Somehow your voice is very mangled when I listen to it here.
Yeah, I
Maybe
can
some-
repeat the question. So the question was the chittis, right? The Sena chittis that you mentioned, were they also Yagna Kundams?
Yeah. Chiti and Vedi both mean Yajna Kunda. They are synonyms. Yes.
Dhanyawadaji.
Thank you. These are some among the theorems that are well-known theorems that are there in Shulba Sutra. I'll leave it to you to later visit them and then see. This is beautiful publication by Vibhuti Bhushan Datta and A.N. Singh called the Hindu Geometry. It's in the Journal of History of Science. I think right now it's also available in archive.org, I suppose. So they bring out all the theorems that are there in Shulba Sutras. So that was the Vedic era. When it comes to classical era, we see Panini's Ashtadhyayi had methodologies that had mathematical influence in them. Null operation, like Lopaha operation, right? Then we also see like a formata when it comes to writing compilers. Similarly, you see such logical deductions, in the Panini and Ashtadhyayi. Then we see in the Chanda Sutra, the what we call today as Pascal's triangle, Meru Prasthara, is there in the Chanda Sutra, and the binomial coefficients are listed in Chanda Sutra. Foundations of combinatorics are there. All the binary number operations. Today we learn when we convert decimal to binary, base 2 numbers, and then we learn a few operations in foundational computer science. All that is available in Chanda Sutra. Similarly, Buddhist Jainist literature, they also thrived in this period, 600 BC to 400 CE. They also, as part of their spiritual pursuits, it was important that they also learn good amount of mathematics. A lot of debate around infinity and zero are found in these traditions. The Jains consider Ganita to be an important part of their spiritual study. Even now, there are various Jaina Ganita Patashalas. So similarly, in the Peshawar district, the Bakshali manuscripts were unearthed in the 1920s. That again, it dates back to very early Common Era. Still, carbon dating of it is not conclusively done for the Bakshali manuscripts. It shows a great amount of mathematical nuances. A farmer, while plowing the soil, he had come across a trove with various manuscripts in them, so they are called the Bakshali manuscripts. They contain a lot of mathematics in them. They are an incomplete collection of a text, but very nuanced mathematics in them. And the salient Ganit, Chandas, I'll dedicate a different class to it, so I'll skip this slide now. The Pascal's triangle, we'll arrive at it, we'll construct it. The 5th to 12th century CE, this is where we see the period taking off from Aryabhatta, Varahamihira, Brahmagupta, Bhaskara 1, and so on. We see that by this time we had fully perfected most of the arithmetics, algebra, geometry, trigonometry, and commercial mathematics that are taught today in schools. You can find them all in their text, in early texts. They also made great advances in solutions to indeterminate equations, both first order and second order. Then computations of sine tables very ingeniously through recursive functions and so on, combinatorics, and other topics which are not even taught at the school level are also there in their texts. Aryabhatta's Aryabhatiya, it has most of the procedures that we know today in arithmetic, algebra, geometry, and trigonometry. We see Varahamihira's compilation of Pancha Siddhantika and Brihat Samhita having a great amount of mathematical work in them. But there is a very interesting magic square in Varahamihira's Brihat Samhita. Then Bhaskara 1, he wrote, we are very, very thankful to Bhaskara 1 who wrote the Aryabhatiya Bhashya. Then things that he could not fully explain, he wrote a Mahabhaskariya and Laghu Bhaskariya to bring out more nuances, more theorems, more proofs, and so on. Similarly, Brahmagupta, Brahmasputa Siddhanta, a complete astronomical work, had a good portion of it dedicated to mathematics as well. Khandakadyaka, what an interesting name for a mathematical book, right? Khandakadyaka means a Kalkand. I don't know what is Kalkand in other languages where you come from, Bharat. Kalkand is sugar candy. Okay. We would have seen a traditional in our homes all earlier, sugar candy, right? So who names a math book sugar candy, right? It's amazing. So that sweet is his text, right? Where we see elaborate understanding of the mathematics of zero and negative numbers, how to treat them, and so on. Uh, Similarly, cyclic quadrilaterals, very, very ingenious calculations of cyclic quadrilaterals and how do you arrive at their areas and so on. Then development of algebra, both linear, quadratic, determinate, and indeterminate equations are all Brahmagupta had advanced all these. The Bhaskara the second is an avid bhakta of Brahmagupta. Then 8th to 11th century flourished many mathematicians who were nuancing the way in which they were writing text. They started writing more enticing texts, like the Ganitasara Sangraha of Mahaviracharya we saw. Sridhara, Lalla, Govinda Swamin. In their works are all amazing. Especially the Sridhara's Ganita Tilaka. Yet to come out, it's still being studied, the manuscript of it. Just brilliant, brilliant composition. I'm sure that is what should have actually inspired Bhaskaracharya to write Leelavati, I somehow feel. Similarly, works of Pritudaka Swamin, Munjala has done great work when it comes to, some among the algebraic breakthroughs. Aryabhatta the second was there. Sripati, correction. So Sridhara did not write Ganita Tilaka. Sripati wrote Ganita Tilaka. Then Jayadeva, all of them had marked contributions when it comes to Indian mathematics. However, they are not quite popular as much as Bhaskaracharya and so on. However, they deserve a very important space. All their works are fascinating. You just go through the table of contents of these source texts. They're very, very inspiring. Then Bhaskara the second came. He took the world, mathematical world, by storm. At least 5 remnant works that we have of Bhaskaracharya. Leelavati, Bijaganita, and Siddhanta Shiromani are very, very popular among them. Karana Kutuhala and Vasana Bhashya are not so very well known, except for some scholarly circles. They became the canonical texts of Indian mathematics and astronomy. The Upapattis in Bhaskara's Vasana Bhashya, they give us the pedagogical advancements of that period as well. We see Varah Mihra giving the sine values that today we study, right? Sine 30, 1 by 2, sine 45, 1 by root 2, sine 60, root 3 by 2, sine 90 is 1. All that tabulation we see in Varah Mihra, the earliest such tabulations that are available when it comes to trigonometric functions. All these trigonometric identities have been captured in the Pancha Siddhantika. The very word sine today actually comes from Sanskrit, because this Ja or Jiva, which was the name for the chord, we will see also, we'll try to dedicate some time to understand and appreciate trigonometry greatly, because today we think trigonometry is to do with triangles. Actually, it's to do with circles in the Indian tradition. We will learn about them. So this Ja and Jiva, this Jiva, because Ba is not there in Persian and Arabic language, it became Jiba, Jeb, became the Al-Jeb. Even today, in so many Indian tailoring households, they say Job which is at a Jeb which is at a Job. Job means a pocket or a crevice in when they stitch a shirt and so on. So Al-Jeb, that crevice or a pocket or a cleavage, all that means Al-Jeb. So that got translated as sinus. Until today, we read it as sine, and so many so many young learners of mathematics curse trigonometry, wondering who on earth invented trigonometry and these sine functions and so on. We must be very clear that the Indians played the massive role in bringing this forward to the world. And cotija became cosine, ja became sinus. So all this is very, very interesting. They all have origins in the Indian tradition. We will also try to dedicate in a later module throughout this course. If it's not too overwhelming for you, we'll try to look into some trigonometrical aspects as well. So essentially, it comes based on manipulating angles in a circle and then working with them. What was brilliant is that Aryabhatta gave an analytic recursion function, recursive function. By knowing, the previous value, you start with a one known value for a very small theta, you give sine theta as theta itself, and then you start recursing through and then finding the values through this relation for all other values of theta. Similarly, this, if you work with it, would come as the discrete version of the harmonic equation. This is quite amazing. The kind of this is the first order sign differences that he had given. This is what he was saying as the differential function in the finite difference form. You'll see that this corresponds to some cos values. So he divided the circle into 24 parts Aryabhatta, and then he gave 24 tabulations. He used the Aryabhatian number system. See, for example, this is the sine table. When we were all studying long back, there were the Clark's table. We had to look up to the table book to find sine values, to even find probabilistic distributional values. All that, the tradition of tabulating such values was started by Aryabhatta. Maki, bhaki, bhaki, dhaki, naki, nyaki, nyaki, hash, jas, kaki, kish, dash, kaki, kikwa, dhaki, kigra, hakya, dhaki, kicha, skash, jangva, klapta, pachakala, dhajaha, are all the first order sign differences he has given. The Aryabhatta number system. We will learn the number systems also in an upcoming module. But I just want to take this session to definitely overwhelm you that a lot of things have happened in Indian mathematics that we should make ourselves aware of. We should make content from this available to our children over time. And that's what our foundation is working very, very keenly. So this is another beautiful verse where can you make trigonometry into arithmetics is the pursuit that they had. And so it's unbelievable, unseen anywhere in any traditions across the world, to bring a rational approximation, an arithmetic approximation to sine values, correct to almost 99% accuracy through through a sort of simple arithmetic values. This led to a door of Maharashtrian school of mathematicians over time, like Ganesha Devagnya and so on. They vowed to teach all of complex trigonometric functions without knowing trigonometry, right? Especially all periodicity functions without having to know sine functions. You can do it only with arithmetics. Was a tradition that was started, and Chakravala method and such very complex advancements had happened by Brahmagupta and Jayadeva, who had all contributed to mathematical analysis of very special functions such as this. So what happens is, the German mathematician Hermann Henkel, he says that it is above all praise. It is certainly the finest thing which was achieved in the history of numbers before Lagrange, he says. This is a very Eurocentric view, right? Called, how to find beautiful cyclic solutions to the, these kind of, by two variable, right, quadratic indeterminate equations. All this is there. Brahmagupta arrived at this, and later Bhavana principle and Chakravala, they were all mastered in the Indian tradition. Right? This Bhavana means binary composition. Right? This was brought out by Brahmagupta. Later, in modern algebra, number theory, we study all of this. Bhaskaracharya, right, in Leelavati gave many verses. We saw all this happened in the classical period. So we are almost close to our time for the day. However, this module, we have just tried to brush through some among these periods. In the coming modules, we'll try to delve one by one and get a taste for something that is very relevant right now. From a select, components from the vast ocean of literature in Indian mathematics, how to draw from it a few important gems and how to present this to our children, and then so on, are things that we will learn in the upcoming lectures. I'll pause it here so that we can continue in the next session, but I'm happy to take any questions or further discussions that you would like to have, or if you want me to continue, I'm happy to continue as well.
Any questions or comments?
Comments, awareness that how much we don't know.
True.
Very
दीप्ति जी, या जस्ट पूरा दिमाग ऐसे खुल रहा है कि ये सब क्या है, कुछ नहीं पता इसके बारे में. थैंक यू सो मच आचार्य जी.
Yeah, thank you, Ji.
But a question है Acharya ji, like these things that we are getting to know today, like for us, for me, it's today. How can I, like, what should be the next? How can I use it for my children or the coming generations to, like, what should we do next? How much should we try to know more about it?
I have a two-part answer to this. I'm sure Anandji and others would have more to add, but I have a two-part answer to this. Ji. One, let it emerge. Please continue in this course. Be very keen, be very attentive, be very rigorous about this. I knew none of what I'm presenting right now. Okay. I knew none of this because we are all product of the same Macaulay education system. And it is just your interest that will reveal many, many things to you. So this course should be eye-opening. And of course, Anadi has published various books for children that are at children level. They are available at anadi.org/IKS edu. But good, willing members who are come together to organize this course there and themselves are taking very serious efforts to bring this knowledge system to our children. So for the time being, soak in is what I would say. And over time, solutions are all emerging your way, Rimaji.
Thank you so much, Ji.
Thank you.
I see Dharamchandji has a question.
Yeah, namaste ji. Definitely a lot of information to digest for the next few days.
Hope no indigestion.
Yeah. Even that takes time to get out of it. So, a couple of points. Number one is that I was so happy to hear that you just did the, Annadanam, I guess you mentioned earlier. So,
Yes, yes.
how would we go about doing such? How can we contribute towards that? That's one thing that emerged early in the session today. And then, how is that impacting the society there locally? I know you're outside of most metro cities. Just realizing that.
Yes. When it comes to Gurukula education, this is part of our ashram initiative. Shriman's vision was to do Annadana at 6 places, thereby creating a learning opportunity for all of us to learn. The earlier ideas of a Gurukula do not do justice to what, the kind of modern media portrayal of Gurukulas. Think about, someone under a tree, sitting under a tree and then with a handful of children, learning something. What were they learning? All this has largely been a black box. So unearthing that has been a very key pursuit for us. And as part of that, we see that Pancha Kosha Vikas has been the central idea when it comes to child development, human development in itself. Be it a Dhanurvidya Gurukula, be it a Ayurveda Gurukula, be it a Natya Gurukula, all of them in their DNA earlier had the development of the child. In the Indian tradition, Sarvam Khalvidam Brahma, everyone is indeed eternally divine. There is no eternal damnation here. So in such a case, then what do you teach a child who is already inherently divine? So that's where the 5-dimensional faculties, the Annamaya Kosha, Manomaya Kosha, Vijnanamaya Kosha, Pranamaya Kosha, and Anandamaya Kosha, these 5 dimensions, how do we develop them, has been the principal approach when it comes to having a very fulfilled and a satisfied life in building Parakramatva along these dimensions. In that, the Manomaya Kosha is largely held captive by Raga and Dvesha. All the time, the mind is processing likes and dislikes constantly likes and dislikes. And to keep the likes and dislikes away, certain seva opportunities help us build great manobhala. And one such opportunity is to do Annadana to Padayatris. Yesterday was Panguni Uttaram. It is the auspicious tithi of the Shiva Parvati Tirukalyanam. That is the divine marriage of Shiva Parvati, which led to Kumara Sambhava. So in all Kumara Kshetras, the Uttaram Nakshatra of the Panguni solar month is very grandly celebrated, where bhaktas come in great amount of padayatra. It's a great experience for Gurukula children, all the ashramites, to plan, mobilize resources, go to places which are not, easily accessible, and then go locally source resources and cook by our own hands, and then serve with our own hands hundreds of devotees. It's a phenomenal learning experience, and the joy of it is unparalleled. How to contribute to it? You can definitely virtually support our Anadhana through anadi.org. You can go there and support us. Or when you're certainly in Bharat, see, we are definitely planning some upcoming camps in July. And do please look out for some among the initiatives that we do here. And you can always come physically and also participate in some among this. And definitely, if you want to take such initiatives ahead, you can write to us. We'll see what we can do at different kshetras as well.
Dhanyavad, Raji.
Thank you, Ji. Thank you for all the wonderful comments here as well. I hope this has been a very productive Saturday morning for all of you. And I hope to continue these discussions. We are just beginning, right, to just scratch the surface. And there are more and more mind-blowing things coming our way in the as we unravel a bit of Indian math and so on.
Right.
Thank you
Brahmachari,
all.
Gurupriya ji, thank you so much. This was a very, very enlightening session and very informative and an intriguing session. For just some of you, just going to do a shameless plug here. For those of you interested to learn a little bit more about our history, there is a book written by one Bhasar Kamble. Maybe Brahmachari ji, you must know about this. It's called Imperishable Seed, and the title of the book is How Hindu Mathematics Changed the World and Why This History Was Erased. Bhaskar Kamble is a IIT PhD from IIT Kanpur, and if you're a history buff like me, you can probably read about some of the things Gurupriya ji was talking about and how the Europeans kind of appropriated all of this into give a European names to it. So, but thank you so much, Gurupriya ji. Wonderful session, and we look forward to connecting next week.
Certainly, I'm just dropping in a link for the children book question that was asked by Reema ji. And definitely Bhaskar ji is for us, the adults. For children, I recommend you to go to anadi.org for IKS books as well. We'll continue our discussions in the upcoming Saturdays as well. Hoping to see you all again and again. And let's let the journey be together. Maybe all awaken ourselves. Maybe awaken many more children and people around the world. I think Prasad ji has raised his hand. Are we out of time, ji? Or should we?
No, go for it. Go for it.
Yeah. So, what's the modern challenges using these techniques, right? What's the modern challenges we are solving now? Do you have any using the whatever the ancient things we have it? What's the modern challenges the research is doing, or they are trying to solve? Do you have aware of anything, G?
Okay. So again, it's not about a modern challenge alone that we are trying to solve. It's not about a modern application. The first challenge that certainly plagues us is poor educational models, right? To teach, mathematics in a very interesting way. This is a relevant application. Number two, this is quite useful. Knowing Indian mathematical algorithms are quite useful in computational thinking as well, in learning computer sciences and its foundations. However, it's just foundational mathematics, right? You're learning it all throughout the world. You don't ask the same question when it comes to a Greek-centric, a Eurocentric mathematics that we anyways blindly consume. Just that the approach here is very organic, it's quite different, and it's very more engaging pedagogically, thereby creating an opportunity to enrich the current educational model, drawing from some among the pedagogical techniques in Indian mathematics. That is one direct relevant application. But certainly, like a lot of other applications are there. For example, I just submitted a few questions. I'm not allowed. This is on recording, so I can't really say. But see, JEE questions and JEE cracking, CAT cracking. A lot of competitive test cracking. You can really rely upon Indian mathematics to build various mental arithmetic skills. In an AI-ridden world, how are we going to hone our own personal skills is always a question. And so how relevant would we always be in such a scenario as well, to hone our own, neurological growth, some among these, pedagogical approaches will be very relevant right now for self growth as well. We will, as we unravel some among these, you will begin to see the joy in them, and you will begin to see the lateral thinking approaches that it enriches you with.
Some of these chandas, right? It's very difficult to read those the Sanskritam from the Lilavati Ganitam to understand that sloka. What's the inner meaning of it? So how we can read that verses and make use of before even reading there, you need to understand about Sanskritam and be familiar with the chandas, then you can actually decode what the problem they are trying to solve.
Yeah, ji. So how do I best answer this? Okay, few things. We do chanting classes, Leelavati chanting class, multiple batches we have had, where we teach how to chant and learn Leelavati. Not word by word meaning, but just chanting. Of course, various scholars have made Patwardhanji, so many others, even the Chinmaya International Foundation, they've all published scholarly translations of Leelavati. Those are also available. If we can teach ourselves a non-alpha syllabic, very unrefined language like English, just because of its practical purpose, Sanskrit isn't far away. Sanskrit is very much in our DNA, and it's very close to all the vernacular languages that we have learned. For the time being, do not get overwhelmed by this. Do not look at this as a problem per se, because we have accustomed ourselves with sigma equal to 110 and so on, such abstract notations very easily, right? Because we have not thought of ourselves as, why am I reading all this? We have pushed ourselves to read it like that. A little push, and you'll be soon finding that this is quite enjoyable, and you can also master many of them.
Dhanyawad ji. Thank you so much.
Thank you. Okay. Is that it, Ji? What?
How many sessions are dedicated towards Ganitam?
I think we have. I think it is 6G. I'm not able to recollect right now exactly the entire plan. I think 6 modules are dedicated to it.
And will you go in detail on some of the slides that we?
Yeah. We're going to drill down on them, Ji. We have looked at the surface level. We'll at least some of them. Yeah, we can't do justice to entire Indian math, but we will definitely be doing something that's very useful for you. So the broad awareness helps you. Then we look at a few areas which are very inspiring, such as geometry, chandas, and a few areas that are very, very wonderful.
Yes. It was very interesting. I'll not take too much time, but the only subject the high schooler in my school, my son's school, can skip and do it in the summers is geometry. And it was very interesting when you said we started with geometry and then we built upon that. So it's like totally opposite of what we are doing in US.
Yeah. Yes.
Right. Very nice. So I just want to leave with one last comment, right? I think very nice answer regarding the application of the knowledge systems, right? I think for Prasadji's questions, as somebody who works in AI, I can tell you, it's unfortunate that the Germans are producing papers about the deontic logic in Mimamsa on how it can make our decision making in AI smarter in self-driving cars. So I think as an Indian community, I think somebody commented here that we are very proud of it, but at the same time, we also need to feel responsible to carry it forward. For us to apply this technology, we need to first understand this technology. And I think that's why we are collaborating with Anadi to help us with that. But, like we told, if any of you is interested to dive deeper into any of these topics and do research and bring out applications and products and services, the knowledge incubator systems incubator is here to support you. So with that, I'm going to wrap today's session. I'll stop the recording. Thank you so much. You all have a great weekend. We'll end with a closing prayer. Sarve bhavantu sukhinah, sarve santu niramayah, sarve bhadrani pashyantu, ma kaschid dukha bhag bhavet. Om shanti shanti shanti. All right. Namaste, everyone.
Dhanyawad.